Let's see if you remember anything from yesterday. If I said x to the 7th is equal to 48, would that be right? X to the 7th is 48. Could you find something to the 7th that would be 48? Yeah. And you wouldn't need logs for it. You could just put this to the power of what, and it would solve it? 1/7. Okay, good. All right. Now, what could you write as a log for this? Will it be log base x, circle of logs, of 48, circling back on logs, equals 7. Now, there's always two ways to write these things. And one way is usually, quote, better. Because the whole point is usually to solve it. Would you agree that the way I wrote it in the first way is kind of better? Because you can solve it by just putting it to the 1/7 power. The one on the bottom, that's not as good. So logs aren't always the answer. Logs sometimes are not as good as just writing it as an exponent. So that was your main job from yesterday, is if I gave you a problem like this, could you even make it into a log? Take a second, make that into a log. Did you say log and then think, okay, I need a base. And what's the base up here? Oh, the base is x. And then it's really common to say 5 next, but it's not 5 next because you do the circle of logs and next is 8. And then back to the 5. Raise your hand if you had that one right. Cool. All right, now with all letters. Log base Q. And then this is going to be R for the argument. And S is a terrible variable because look like a 5, so I'm going to use P. What would that be as an equation? Remember, circle of logs. See, this is a log already, and you're trying to make it into an equation with an exponent. Did you say Q to the P equals R? Raise your hand if you had that one right. Cool. All right, I think you get the main stuff from yesterday. So now we're ready to move on to the new stuff. The new stuff has some patterns that you got to get used to on logs. Let's do this one again. Do you remember what that one is equal to? 1. Because there's a 1 right there, and if the bases are the same, the answer's already there. You remember that dumb little saying? If the bases are the same, the answer's already there. So what if I make this into a -1 right here? What's the answer? -1. If you had to prove it, you could go like this. 2 to the x equals 2 to the -1. And if you look at that, you'll be like, well, obviously then, x has to be -1 because the bases are the same. All right, so bases the same is a really big concept. Did I show you this one yesterday? If so, you'd be able to just tell me the answer. What's the answer? 5. Because the bases are the same. And if you think about it, this is a base because it has an exponent, and this is a base because that's the base position of a log. So they both kind of bases, and the bases are the same. So the answer's already there. It's 5. And again, I can show you the long way, but it takes a lot of time. So I'm trying to show you a few more patterns like this. Like this one might be a stretch for you. I know that the answer to this is not 2 because why? Because the bases aren't the same. Okay. But if I change this base to be a 3, now would you agree that the answer comes out to 2? Yep. Now watch how this is so weird but true. If I take this and I move it down in the front, did I actually change the answer? Isn't it still going to be 2? I know, makes your head hurt. But Isn't this part right here equal to 1 now? And if you times it by 2, it's still equal to 2, isn't it? So yeah, numbers that are right here can move down in the front. And then they're not there anymore. Yes?
Wait, why wouldn't it be log 3 to 9? Because 3 squared is 9.
3 squared is 9, you're right. I'm not going to argue with that. So let's rewrite this out. I said log base 3 of 3 to the second was equal to 2. That's what I said in the first place. Did you agree with that part, that that was equal to 2? All right. So now if I change the 3 squared to a 9, the answer's still 2. It's just harder to see that it's 2, okay? But the part that's really weird is that 2 can be moved to here, and it won't change the value of the answer. The answer is still going to come out to 2. All right, so why does that help you? Because watch this. Everybody write this out. Log base 7 of 7 to the x and let's say it equals 10. Now, it's from now on, since I've explained that this is a truth, you can move that x down into the front. Why does that help? The whole goal is to get x alone, right? I'm trying to solve for x. And it's hard to solve for x when it's up in the exponent. And look at that, it's not in the exponent anymore. And then, what's all that equal to? 1. So now x is equal to 10. Let me show you the alternative. If I didn't do it that way, I left this x up here, I'd have to go this other way, which involves a rewrite, which is a lot longer and more painful. Now, I'm not saying that this is like a perfect solution that's so easy every time. It's just a truth that I can get this x to move down to the front, and sometimes that saves me time. You'll see in some of the problems for today. All right, so that's the first thing that's kind of mind-blowing, is that if it's a power on the argument, it can move to the front. You guys getting that? Yes?
How again do you do the stuff that's like a number to the power of log or something?
Okay, I gave this example of, let's say, 17 here. So the answer for this one was 17. And I didn't want to go through that, but I'm going to go through it really fast because you asked. I'm going to say equals x because you can. Anytime you don't have a variable, you can say equals x. Next thing you do is you say, this is not actually technically a log. It's in exponential form because it doesn't start with a log. So then I can write it as a log base, and then you think to yourself, what's the base? It must be the 8. And then you do the circle of logs again, and you get, and that's why x is 17. It's a rewrite into a log. Now I bet you can see that log base 8 and log base 8 are exactly the same, so then x must be 17. All right, that's all I have time for on that. Now I'm going to teach you the next thing, and I think this is so important that when I was making my tough 20, you know, there's something beyond first 20, and it's called top 20, and then I have another one called first 20, and then I have another one called tough 20, because I'm an ACT tutor, and I need kids to know all their basic math so that they can rock the ACT. One of my proudest accomplishments of this school year is I had a kid come to me for tutoring, and I don't want to say what their original score was, but it was way not a 36. And by the end, they got up to a 35 ACT, and then they got into an Ivy League school. So I'm proud of that. I work really hard to help kids get their, not just their basics down, but there's a lot of strategy on the ACT too. But this I'm about to teach you is base 2, where I felt like it was worthy of going on my tough 20, which is like my hardest sheet getting ready for the ACT. So let's see if I can teach it to you. Log base 2 of x plus log base 2 of 10 is equal to log base 2 of 4. You'll have to answer something like this on your next test. Let me show you how it works. Your first job is, you know how I say if you can factor it, you should? There's something like that for logs. And it's if you can combine the logs and get it from 2 logs down to 1 log, that's always better. Instead of having 2 logs, if you can get it down to just 1 log, it's always easier. So you should combine any that you can. So here's the 2 that need to be combined right here. These guys. I should keep that having a red X. Log base 2 of x and log base 2 of 10. If they have the same base, you can combine them. And take a wild guess what their base will be. Log base 2. And I think for some of you, this is going to feel natural, like it just makes sense to you. It's going to be 10x. Now all I'm doing is copying the rest of it. Log base 2 of 4. Now for some of you, that wasn't just natural. That felt really weird. But it's these 2 that really need to combine, right? Because we already know it's going to be the same base. I know it seems like maybe they should be added. But I can prove to you that they actually need to be multiplied. But it's going to take a bit. So for right now, I'm going to ask you to just believe me that those 2 get multiplied. All right. Because I want to just finish this problem so you can see how it flows. Now, if this is the same as this, it's kind of like those problems where the bases were the same. You remember then it was all about the exponents once the bases got to be the same? So this just turns into 10x equals 4. Once the bases are the same, then the answer was just the exponents. Well, in this case, once the log bases are the same and there's just one on each side, look, no more logs. I just took the logs out. That's powerful for solving because now if you can't solve 10x equals 4, you're in the wrong class. Divide by 10, divide by 10. 2/5? Raise your hand if you had 2/5. Okay, cool. So the thing that really based on was 2 things. One, that if you have 2 logs, you should combine them. They will only combine if you have the same base, and so we're just not going to give you ones that don't have the same base. But if that was like a base 3, you just wouldn't be able to combine them, and it wouldn't be a normal problem then. It'd be really complicated. So they'll have the same base. And if it's add, you multiply here. I have so many things to go through today. I don't want to have to prove that to you, but I bet you're going to get the corollary to it. Don't write this, just listen. I almost never say that. But I think if you get bogged down with too much writing right now, you'll miss the forest for the trees. What would your first step be on this one, and why is it a little different? Ooh, you've got it. When you combine these, show me how there's divide involved. We all know it's log base 3. The other one was plus here, and so it was multiply, and now it's minus, and so you're going to divide them, and you are correct. And when you're dividing, the order actually matters. Because adding, it doesn't matter which way you multiply. Multiply 3 times 5 or 5 times 3, it doesn't matter. But it's x divided by 10. And all I'm doing now is copying. I combined the 2 logs. Then I could take them out. But really, This is not actually canceling these logs. It's just saying, let's focus on the other parts being equal. X over 10 equals 12. And then you just times by 10 on both sides, and you'll have x equals 10 times 12 is 120. Raise your hand if you had that one right. Okay, awesome. Now I want to show you that proof. Let's see if you can process this. You can just watch this. Log base 2 of 8. I already know the answer. Do you? What's that equal to? Isn't 8 2 to the third? So then the answer 3? Okay, good. Plus log base 2 of, let's do something else we know, like 4. Are you with me so far? Okay. So this first one is actually equal to 3, and this one's equal to 2. Would you agree that the final answer for this thing should be 5? So if I was right about how we combine them, you say it's log base 2, because they were both log base 2, right? And then what did I say we should do with the 8 and the 4? Multiply them, right? So what's 8 times 4? What is log base 2 of 32? Because isn't 32 really 2 to the 5th? Right? So if this is really 2 to the 5th, isn't the answer to this 5? And that's what it's supposed to be. Because this 3 plus 2 is supposed to be 5, and it is 5. That's why you multiply them. That and that get multiplied right here. So when it's add, you multiply. And isn't that actually true that add and multiply go together in math? And think about it. What's 2 plus 2 plus 2? 6. Isn't that 2 times 3? Look at that. Adding, multiplying, going together. All right. Now, without any help, see if you got this. Log base 3 of 8 minus log base 3 of x is equal to log base 3 of 12. Solve. This is going to be a little harder to do in your head. Not impossible, but and then I can just focus on this. 8 over x equals 12. And my way of solving that, you have your way, I have my way. I like to clear the fractions out. So I times by the denominator. Boop. And then it becomes obvious. Oh yeah, I just divide by 12 then. 8/12 simplifies to 4/3. Raise your hand if you had 4/3. All right. Oh, question.
2/3.
8/12 is not 2/3, is it? Is it? Oh my gosh. You're right, sorry. 8/12 is like 4 times 2 over 4 times 3. Oh crap. My brain was broken for a second there. 2/3. All right. Okay, one more thing. Prepare to not like this. Log base 1 of 4 equals what? What the heck does log base 1 of 4 equal? At first, it seemed fairly simple. You just go 1 to the x equals 4, right? What's the problem with that? There's nothing. There's no way to do that. There is no number you could put here to make it true. I don't know if you've ever processed that before, but if you have a 1 and you put it to a power, no matter what power you put it to, the answer is 1. You can put it to the 1/2 power, square root of 1, still 1. You can put 1 to the 35th power, it's still 1. You can put it to a negative power, it's still 1, because it just flips 1 over, and it's still 1 over 1, which is 1. So, What does that tell you about this base? This base is broken, and so there's some rules about what can be in the base, and one cannot be a base. So if we gave you that problem, you would say, no solution, base cannot be 1. This is called a domain. Domain is what you can safely put in. You cannot safely put in a 1 for a base. All right, so I'm gonna give you this like note that I would put in my notes. We're gonna call this B, and we're gonna call this A, because B stands for base and A stands for argument. Good. B has to be greater than 0. It can't be 0. It has to be greater than 0. But 1 is greater than 0, isn't it? So I can't just say B is greater than 0. And B cannot be 1. Now, I could make you a number line for this, but that's the easiest way to say it. It's positive, but it can't be 1. It can't be 1. No. It's not just bigger than 1. See, it can be a base of a half. That's legal. It could be a base of any fraction, like 1/2, 1/3, 2/7, whatever. It just can't be 1, and it has to be positive. And this one is simpler. A just has to be positive. If it's positive, you're good. Doesn't matter. The argument can be anything. It just has to be bigger than 0. So a typical trick question on the test, it seems like it's innocuous, is no. Log base 3 of -3. And it's just, nope, there's no way to find that answer. It's an illegal question. If you type it into a calculator, it'll say error or no solution. Because you can't have a negative argument. Same with the base. All right, so there's some rules about logs, the things that it just can't be. All right, there's one more that's like a really handy thing. In a way, couldn't you say you won the argument? See, the one argument? You won the argument. And you know what you get if you win the argument? Nothing. I want you to process that for a second. It's because circle of logs, 3 to the 0 is 1, isn't it? If you won the argument, you'll get nothing. And it's honestly very true in life also. We have a debate going right now in math between two teachers, me and somebody else. And I can win the argument in my head, but still not win the argument in their head. And then all of a sudden, I may win the argument, but I'm not going to get anything out of it. In fact, they just might be mad at me. So, now, there is times I'll give you that winning the argument is important. For instance, if you're in a legal case and you have a lawyer, you want to win. You want to win the argument because there's a decision at the end, and maybe you would have to pay a bunch of money if you lose or whatever. So, yeah, I get it. This doesn't always work. But if you and a friend are arguing about something that's dumb, you're going to get nothing out of winning that argument. Don't have the argument. If at the end you can't get anything out of it, then just don't argue. All right, so if you won the argument, you get 0. It's just true because 3 to the 0 is 1. So if there's ever a 1 here, problem's over. The answer is 0. Okay? All right. I think I've covered it all, but I'm not positive. So I want to look at the homework with you. So everybody open up that worksheet. We're going to skip a bunch because it's a little overzealous on how many problems it assigns. So find the worksheet. I'll do at least one with you. And I'll tell you which ones to skip. All right, on that first one, I think it's just so confusing how it's laid out that we're just going to skip it. So everybody skip problem 1. All they're asking you to do is to try to estimate how big the log is. And we did that on the first day, so skip number 1. On number 2, those are super important and super quick. Like, what is number 2, part A? We are doing 2A. You see it? I see it. Bases are the same. What's the answer? 5. Those are really important. How about part B? I'm going to write it on the board for the people at home. Part B says 5 log base 5 of 2. You should just see it. What's the answer? 2, because the base is the same. The answer's already there. It's 2. All right. Part C, that's one of the ones I said. It's you won the argument. So what's the answer? 0. Yeah, but you stopped right when it was hard. The D one is log base 6 of 3 plus log base 6 of 12. That's the kind I showed you how to put together. Couldn't you put those together and make it one log of base 6? Yes, you could. And then I bet you'll be able to even figure it out. It's log base 6 of, what is 3 times 12? And I bet you'll figure out log base 6 of 36, won't you? All right, good enough on that. So we're doing all of problem 2. And problem 3 is kind of repetitive. We're going to do 3A and B, but we're going to skip C and D. So 3 you're skipping. Brandon, I know this is good, but listen to this. Skip 3C and 3D. Problem 4, also skip C and D. But watch out, because we have things like letter E. Consider it a challenge. It's not like a R4, but I know it's kind of hard. But you should be able to figure out how to make them have the same base. On letter E, try to get them to both have a base of 2/3. You're going to have to do that by putting it to a weird power. Maybe it needs to be a negative power. Okay, so you're skipping problem 1 and problems 3 and 4, just parts C and D in 3 and 4. All right, now you got a bunch of work time. Please feel free to ask me questions. I want to help you. If you want to look at this math challenge thing that's really rare that came out in the breezes, take a picture of it, enter it. It's kind of fun to participate in those things every now and then. That's all I got for you for today.